Welcome to the final exam review, answer key, and walkthrough, I guess. Thank you for watching. This video is just going to cover problems 40 to 44? 40 to 43. They take quite a while. The word problems with sinusoidal functions are going to take a little bit of time. So what I'm going to do is I'm going to show you the answer. So hopefully you've already worked them through. You can see if you got it all correct, then you probably don't need to sit and watch the video. But if you did need to watch it, the explanation will follow. Okay, so problem number 40, have it kind of intermingle here. First it says A, sketch the graph. So I have a sketch of the graph. My axes are labeled, time in seconds, and distance from the wall. Here I have 3, my low is at 3, my midline is at 1.5 and 4.5. I have those midlines labeled, and the highest distance, or the furthest distance away that it is up at the max. Part B, write a trig function for the distance as a function of time. That would be right here. So we set A, B, C, and D, plugged all those values in. C was 125 centimeters and D was that. So if you already got this correct, good job. If you want the explanation, I am going to do it right now. Okay, so it says a calculator can be used. We want to make sure that we're answering correct to 3 decimal places. So we need to 3 places after the decimal. We want to be careful about that. All right, so a ball on a string is swinging back and forth from a ceiling as shown in the figure below. Well, on the side. So over here it's getting close to the wall, it's getting further away from the wall. Close to the wall, further away from the wall. So that distance is R. Let's see, let D represent the distance that the center of the ball is from the wall at time t. Assume that the distance varies sinusoidally with time. So I already know I'm going to have distance and time. So I want to maybe set up my axes. This is time in seconds. And this is distance. And distance in centimeters. It's important that we are writing our units. All right. Then it gives us some data points. Let t equal, when t is 0 seconds, the ball is furthest from the wall at 160 centimeters. So at time 0, we're at 160 centimeters. After 3 seconds, 1, 2, 3, we're the closest to the wall at 20. I'm going to put 20 here and put my point. And then after 6 seconds, 4, 5, 6, not 6 seconds later, when t is 6, the distance is at its highest point again. So here and here. All right, let me make those different colors so we can see them better. We've got pink. All right. So there are a couple things that we can tell from this. First of all, we want to look at this and say, okay, this is the highest and the lowest it goes. Now, if it's sinusoidally changing, then we want to find the midpoint between 160 and 20. So the distance here is 160 minus 20, which is 140. So this total height is 140. Cut that in half, and that's 70, which is my amplitude. I'm going 70 up, 70 down, 70 up, 70 down. Well, I say up and down, 70 to the right and left of the midline. So the midline would be 70 more than 20. So I wouldn't start here and say this is 70 because it's 70 from 20. So we would be at 90. So that would be our midline. All right. So this is going to help us with our equation. So I was doing b over here. Y equals, no, let's not use y. It says d, so let's use d. The distance is equal to, and we're going to put in our a, b, c, and d. So a, looks like we're starting high, so we're going to do cosine of b of t minus c plus d. All right, so d is our midline. So we can start plugging info in as we go. So our midline has shifted up 90 units. 90 centimeters. So we already have our D, and then our amplitude is how high and how low we're going from the midline. So our amplitude is 70. And sometimes it's written sometimes 90 is written in the front, so it's 90 plus 70 cosine B, whatever, and then it continues. But either way is fine. All right, so to finish my graph here, I need to go, well, halfway between 0 and 3 would be 1.5. And that's going to be when I'm at the midline. And then 1.5 would be at 4.5. And that's at the midline. So then we can graph it. It's concave down, and then concave up, and concave down again. So that would be one period of my sinusoidal curve. All right, so in order to find B, we need to know about the period. So the period here is 6 seconds. And our formula for B, for the period, is 2 pi over B is equal to 6 seconds. I want to set up a proportion and go crisscross. So 2 pi equals 6b. 2 pi equals 6b, and divide by 6. And 2 pi over 6 simplifies to pi over 3. So b is pi over 3. So cosine of pi over 3. And then we want to see, okay, is there a phase shift? Did we shift over before we started our cosine function? And we didn't. We started at 0. So we're just going to write t in there. And that finishes our equation. Now, I think it would be a really good idea to type that in your calculator and make sure that these points fit correctly. So we're going to go to the calculator, type in y equals. I had some. Okay. So we're going to say 70 cosine of the quantity. So it's important that we put a subset of parentheses, pi divided by 3, close that inner set, times t, which is just x, and then close that off, plus 90, and graph it. Now, if your graph is not set up with the right dimensions, you're not going to see it, like is the case right now. I see nothing. Also, I am in degree mode, so once I can see it, it's still not going to be correct. So let me show you what it'll look like. If I want my window, I know what my window should be. It says it right here. I want to see from 0 to 160 on my y. So my y values, I want to see as low. I like to do -1 just so I'm a little bit below the axis. And then I want to go at least up to 160, so I'm going to say like 170 so I can see the top. Now I don't want to do scale by 1 because it'll be 171 tick marks, and I don't really want to see all of those. So I'm going to count maybe every 20. So that means it'll just be a tick mark every 20 units. All right, and then the x's, I only need from 0 to 6, but I'd like to see maybe from -1 to maybe 10. All right, and then I'm going to count by ones. All right, so we can graph it, and now we should be able to see it. All right, now I see something. That is definitely not a sinusoidal curve. And the reason is, like I already mentioned, is we're in degree mode from another type of problem. So here, we are definitely in radians. Okay, so word problems with sinusoidal functions, we always want to be in radians. And you change that by going to mode and going down here and hitting radians. So down, down, and then hit enter. And that'll change it to radians. So you can quit out of there, second quit, and then graph it again. And it should look like what you want it to look like. All right. All right, so now I think it would be a really good idea to check our data and make sure that I've written this equation correctly. If I trace 3, I should be at 320. That's a data point that they gave, so I can make sure, okay, all right, the equation that I have correlates with the data given. I could also check after 6 seconds. Yep, I'm at 160. Great. All right, so I'm on the right curve. This is the right. I'm sorry, I say right. There are other correct answers that you could have given here. If you wanted, you could have moved here and done a negative sign. You could have done a shift to 1.5 seconds, or you could have done a shift to 3 seconds and had a negative cosine, or you could have done a shift to 4.5 seconds and had a positive sign. So there's all sorts of different equations that could have gone here that would have matched this data as well. All right, so what is the distance of the ball from the wall at time t is 5? So we're going to trace 5 and see what happens. It looks like we are 125 centimeters away from the wall. So 125 centimeters. So we just hit the trace function if we're given a t. But if we're given a y value or a distance value, what is the value t the first time the ball is 40 centimeters from the wall? Well, I can't type in the y and get the x out. So what I need to do is go into my y equals and draw another line. I'm going to do maybe purple. Okay, so the other line is at 40 centimeters and graph. Aha. So now I want to see where do they intersect. And here it says for the first time. So I'm just looking at this value right here. What time is that? Well, it looks like 1, 2, and a tiny bit. So I'm going to hit second calc, and I want to calculate the intersect. Oops, I don't want to do y dx. Let's try that again. Second calc 5. All right, so the intersection is going to ask me 3 questions. Is this your first curve? Yes. Is this your second curve? Yes. And then guess, what do you think it is? Now I can either put in I can just put in 2, well I think it's about 2, and hit enter, and it'll give me that. Or I can move my cursor over, and get it close to that. So I need to round to 3 decimal places and be really careful about that. So 2.2597, but 597 would round, I go to the third one, and that's going to round up to 10, so that's 60. So 2.260 seconds. At time equals 2.260 seconds, we are 40 centimeters from the wall the first time. All right, so hopefully that helped if you hadn't gotten that correct. All right, let's check the next one. All right, here are the answers. So if you want to pause, go back, try it. So this is very similar. If you want to try it on your own, that would be great. But here are the answers if you want to check your work. All right, yeah. So the graph would look like this. Oh, this is just my little sketch. You didn't have to do that. It just said write an equation. So we went A, B, C, D, plugged everything in, checked at 11.5, and then found the first 2 times when the height was 70. All right. So if you got those right, or maybe you don't need to watch this. All right. But here is the full explanation. So Sarah's riding a Ferris wheel, and her sister Carrie starts a stopwatch and records some data. Let H represent Sarah's height above the ground at time t. So we've got height. The first one says write a trig function, so A. The height is with respect of t, we're doing t, so we're going to have an A. It's either be sine or cosine. We're going to have a B in here, t minus c plus d. So this is our setup, and we're either going to have sine or cosine. All right, let's see. Carrie notices that Sarah is at the highest point 80 feet above the ground when t is 3. All right, so I like to have a quick little sketch just because it helps me visualize it. After 3 seconds, we're at 80 feet above the ground. Okay, when t is 7, 4, 5, 6, 7, Sarah is at its lowest point, 20 feet. All right, 7, we're at 20. Assume that the height varies sinusoidally with time. So we are at the highest point, at the lowest point. We have to have gone through the midline. So 4, 5, 6, 7. There were 4 units, so halfway we're going to be at the midline. Well, we want to find what is that midline. We're coming down like this. We're going down like that. If we go backwards, well, 2 seconds forward, we're at the midline. 2 seconds back, we'll be at the midline. So 2 seconds back, we're at the midline. So I'm going to continue that. We're at the midline at 1 second. And then again, 8, 9. So at 9 seconds, we're at the midline. All right, so where were we? Let's see. We want to find the midline. So 80 minus 20 is 60. So there are 60, let's see, feet. Are we talking about feet here? Yes, there are 60 feet that we're changing. So if we cut that in half, that's 30, right? So our amplitude is 30. So we're going 30 up, 30 down. So this distance is 20 plus 30 would be 50, right? So the midline is at 50, so that's right here, 50. All right, so I'm gonna decide to do a sine curve starting at 1. Now you could do a cosine curve starting at 3. Either way, it's what do they say? Neither here nor there. It doesn't really matter. So I'm gonna say sine, and we have to find the period, and then we have t minus 1. So my shift is 1 second later it started a sine curve. And then we need to find our b to get the period. Oh, we need the period. Okay, so it looks like from 1 to 9 would be my full period, so 9 minus 1 is 8. So 8 seconds is 1 full period. We could have gotten that by 7 minus 3. The distance here is 4, and that's half a period, so double that. Or you can go 9 minus 1 and the full period. So 2 pi over b equals 8. So crisscross, and we get 8b equals 2 pi, divide by 8, and b equals pi over 4. So we're going to put in here pi over 4. All right, so that is A. B, I'm going to hit pause and plug that in my calculator so it's all ready. All right, so I just typed this in my calculator. One thing I need to note is I also put parentheses around this because it is a fraction. So the sine of pi over 4 times x, the quantity x minus 1, and all of that in parentheses. So make sure that you get all your parentheses in there or it will mess up. Okay, I also typed in 70 because a little foresight here that we're going to be checking out 70 feet. All right, so I'm going to graph that. Now, when I typed in my dimensions or where I wanted my window to be viewing, obviously it was okay. I didn't need to change it so much, but it looks like right here we have to check 11.5 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I only go out to 10. If I hit trace 11.5, it's going to say error. Well, okay, I didn't really make an error except that it can't see this point that I'm asking for. Okay, so I want to go to my window and change that max to maybe 15. And then I will be able to see it. Okay, so at what will Sarah's height be after 11.5 seconds? We're about to find that. Your answer should be correct at 3 decimal places. So her height after 11.5 seconds, sorry, is, let's see, trace 11.5, enter, and it looks like 77.1, oh, sorry, 716, and I don't need to round up. So 77.716, and we need units here, so we're talking about feet. Very important. If you're given a word problem, you definitely want some words in your answer. All right, so that would be, and we use the trace function. Okay, on this last one, determine the first 2 times. Okay, so we need 2 different values here when Sarah's height is 70 feet. Your answer should be correct to 3 decimal places. So the first 2 times, we need to find these 2 intercepts. So we're going to go second calc. Sorry for that interruption. Okay, so let's see, what was I saying? Okay, we want to find those first 2 intersects, so I'm going to hit 5. And I'm going to go first curve, yes. Second curve, yes. My guess is 1, 2. I'm going to say 2 is my first guess. Aha! So this is my first time I hit 70 feet. After, oh, yeah, okay. After 1.9291. Okay, seconds. Now, I just had a question mark in my brain for a second. I thought, wait a second. Determine the first 2 times when Sarah hit that many feet. I was like, wait, but they gave us after 3 seconds, we started here. So I wondered, was it after that? But then I saw this, and it clarified for me. From t is greater than 0. So from the very beginning, what are the first 2 times? Okay, so we've got 1 there, and then the other one, second calc, intersect, first curve, second curve, and instead of guessing a number, I'm just going to tap this to the right, and I'm going to guess that it's about right there. And there's my flashy cursor. So I'm going to enter. All right, so the intersect is at, oh gosh, I can't quite read that, 4.07. 4.0708, but that's going to be 0.71 seconds. All right, so those would be the first 2 times that we hit. I'm just going to go back and make sure we agreed with the last page. Yep, okay, great. So those are the answers. I hope that helped. Problem 41. All right, 42. Again, we just did 2 sinusoidal word problems. So if you're having trouble with them, hopefully those tutorials helped and you could do this one all by yourself. So again, hit pause, try it on your own, because it's a lot more informative for you to try it on your own than for us to do it for you. All right. But here are the answers if you've already done it. Here is the graph, which was A. B said write the equation. This was the equation. Again, you could have a different equation if you started somewhere else. And at 1:45 a.m. was C. Okay, so let's go ahead and go through that completely. So the first question says, sketch and label a graph showing the depth of the water as a function of the number of hours after midnight. So A, I know I'm going to be sketching a graph. So this, they said depth of the water, and I want some meters. And this, they said time as a function of the number of hours after midnight. Time, hours, since midnight. All right, so let's go ahead and read the problem. At Ocean Tide Dock, the first low tide of the day occurs at midnight. Oh, that's pretty easy. Okay, so 0 o'clock. The depth of the water is 2 meters. So we're going to put a 2 and put a point. Okay, we're at low tide. And the first high tide occurs at 6:30 a.m. 1, 2, 3, 4, 5, 6. That's 6 o'clock. That's 7 o'clock. So halfway between that, we're going to be at the high tide. All right, so between 6 and 7, we're at the high tide. And the high tide is 8 meters. I'm going to start talking faster because we need to get out of this. All right, here we go. So halfway between that, 8 minus 2 is 6. So there are 6 total meters here. So halfway would be 3 up and 3 down, so that would be 5. So the midline is at 5. All right. So again, this is helping to inform us of our equation. So low, high, assume that the depth varies sinusoidally. Okay, so halfway between 0 o'clock and 6:30 would be 3:15. So 3:15 is about right here. At 15 minutes would be a quarter, right? 3.25 would be here. So I'm going to go up. And then I'm going to keep going with that same pattern the other way. So if 6.5 is half of a period, I would double that. So 6 doubled is 12, and a half doubled would be 1, so 13. So at 1 o'clock, but we're going to say 13. So 7, 8, 9, 10, 11, 12, 13. Right? Because this is hours since midnight. So 1 o'clock would be 13 hours since midnight. So from 6:30, let's go backwards. 1, 2, 3 hours and 15 minutes, a quarter, is going to be our midline. And then at 13, we're going to be at our low again. We're going to be at low tide at 1 o'clock. All right, so that would be our graph. I might want to label this. So this would be, let's see, hold on, 6:30 plus 15 minutes would be 6:45 plus 3 hours. 7:45, 8:45, 9:45. So 9:45 or 9.75, 3/4 of the way through the hour, we would be at the midline again. All right. So B tells us to write the equation, determine the trig function that models the graph. So we want depth is equal to A. This looks like a cosine function to me, but a negative cosine. So I'm going to put cosine B of T minus C plus D. All right, so let's start plugging in. D is 5. A amplitude is 3. It's a negative because it got reflected over the midline. Then we have cosine. Our period is 0 to 13. 13, and we just take 2 pi over B equals 13 over 1, crisscross, multiply, and B is 2 pi over 13. We got T minus C. Is there any phase shift here? And since I started here, I had no phase shift, plus 5. Okay, so that would be my equation. I'm going to pause it. All right, when I typed it in, -3 cosine, I made sure to use this negative, not the minus. 2 pi over 13 is in a subset of parentheses. Oh, look, I forgot a parentheses. We've got our outer, forgot to finish off my parentheses. So I had a subset, and then I forgot my second parenthesis. So that would have messed us up. I'm glad we saw that. Okay. Okay. No. We're going crazy here. All right. Plus 13. Okay. 1, 2, 3, 4, 5. Okay. So I could hit second insert and put a parenthesis in there without affecting anything. All right. So now we have our inner, and outer. Graph it. Oh my goodness, it looks like my calculator is broken, doesn't it? But remember, we had from 0 to 160. Here, all we need is 0 to 8. So this is just really 0 to 8, and we need to change our window. So I'm going to go into my window, if it'll let me. All right, I had to finish graphing first. So my x min is 0. I want 0 to 13. Well, 0 to 15 is good. I can keep those dimensions. Scale of 1 is good. My y min from 0 to 9. All I need to go up to is I like to go 1 past it. We can't jump by 20. That won't make sense. So we're going to jump by 1s and graph it. That should be a lot clearer. Again, I might want to check. Okay, 0, make sure I'm at 2. 6, make sure I'm at 8. 1, 2, 3, 4, 5, 6, 8. All right, looks good. But I might want to actually trace that. Okay. Sorry, I'm in a slight hurry here. Okay. So, determine the trig function. We graphed it. We looked at the function. Now we want to suppose a ship requires at least 3 meters of water depth and is planning to dock after midnight. Determine the earliest possible time that ship can dock. So 1, 2, 3. I also graphed a line at 3. So when's the earliest possible time? After midnight. Well, the water's too low. Water's too low. Here it can dock, and then anytime after that it can dock, right? After midnight. Well, not anytime, between here and here. But we need to find that time right there. So I'm going to do second calc and do an intersection again. All right, so first curve, enter, second curve, enter, and guess, my guess is about 1.5. And it's 1.7. Okay, so we're going to put this in at 1.740 hours. Now, what time is that, though? If you have 1 full hour, well, that's 1 a.m., right? And then if you have 0.74 hours, well, how many minutes is that? You can multiply by, well, how many minutes are there in an hour? There are 60 minutes in 1 hour, so that cancels out your hours. What's 60 times 0.74? Oops, I didn't mean to do it in there. All right, we have to get out of the graph real quick. Okay, 60 times 0.74. would be 44.4 minutes. So at 1 a.m., after 1 hour and 44.4 minutes. So I would say, to play it safe, I wouldn't want to go at 1:44 a.m. I would like to round it up to 45. So at 1:45 a.m. I think that would be a safe time for a ship to be able to pass and not hit the bottom, right? At 1:45. Sorry, my graph is not completely drawn to scale. We're going to undo that line because it, whatever. All right, so that was the ocean dock problem. Hopefully that's helpful. And the last one, this one was a little tricky. I may need to go and do a separate video for this, but the answers are here. I think I'm going to stop this video at this time and do this one later because there's a class coming into this classroom. All right. So I will go through this problem in the next video. All right, thanks for watching.